All right, I'm going to go ahead and apologize now for my voice. Hopefully it's not too painful to listen to. We are in section 5.6 using, here's a big fancy word, multiplicative inverses to solve equations. All right, multiplicative inverses. You do not have to write this entire definition. Here's what I want you to write. The multiplicative inverse is the number's reciprocal, and that should be familiar to you, a reciprocal. So let's take the number 3/4. What is the reciprocal of 3/4? No, the reciprocal, 4/3. And my rule is multiply it by its reciprocal, and what does it equal? 1. It cancels, essentially. Okay, so that is a very important part to what we're learning in the lesson today, is how you can use the multiplicative inverse to solve equations that have fractions attached to the variable. Okay, so this is how it looks when I'm multiplying. And you just saw this, what I did at the bottom, but you don't have to write this down. Here's the property. The product of a number and its multiplicative inverse is always going to be 1. And that's what we want. We want it to cancel out. And we know that 1 in a variable, 1x, is the same thing as just x. All right, so that's what the property is talking about. So now here's how it looks in example 1. I have this equation, 4/7 x equals -12. Well, my goal still is to get x by itself. So I need to get 4/7 to cancel. Well, we just said that we can get it to cancel by multiplying by the reciprocal. Okay? So what's the reciprocal of 4/7? 7/4. All right, these cancel, and yes, I want you to show, yes, physically that they cancel. And they cancel to 1, but do I have to write the 1x? No. Just write x equals, but wait, whatever I do to one side, I have to do the same thing to the other side. Multiply this side by 7/4. Can I cross-reduce anything?
Yes.
Wait, is it 12 and 4? -12. So when I cross-reduce the negative, I've got to keep it. What's -3 times 7? -21. X equals -21. Okay, I want you to try the second one. 2/3 x equals 22. Okay, multiply both sides by 3/2. They cancel. Multiply the other side by 3/2. Can I cross-reduce? Yep. X equals what? 33. All right, now on the third one, what do I need to multiply by to get x by itself? Jared?
9/5.
Not 9/5. L'Ariel? -9/5. If it's negative as a coefficient, I must multiply by the negative reciprocal. I've got to take the negative with me. So now I multiply by -9/5. Guys, why am I putting it in parentheses? Because it's a double sign. Very good. It's a double sign. Can I cross-reduce? Yep. -3 and 1. And what's -3 times -9? Why is it positive? Two negatives, not double negative, but two negatives, even number, positive answer. 27. Now for the harder part of the lesson. Now we have two-step equations. Okay? There are multiple ways that you can solve this. Multiple ways. I'm going to teach you the way that the book covers, and that is finding LCD. But we're still going to follow the same process that we follow when we solve a two-step equation, and that is that I have to move first what is not connected to the variable. So how can I get 4/5 to cancel to the other side? Subtract. Do the opposite. The rule is still the same to subtract 4/5. Subtract 4/5 from both sides. All right, and now I get negative 11/15 x equals, but wait. Look, guys, look up here. Can I do 1/3 minus 4/5? No, I can't. What do I need? An LCD. So what would my LCD be? 15. And then I keep my subtraction sign and a 15. I want you to try to figure out what your numerators would be. Okay, so first numerator is going to be a 5 because 3 times 5 is 15. So 1 times 5 is 5. What about my second one? 5 times what is 15? 3. So 4 times 3 is 12. All right, what is 5 minus 12 now? Negative 7. So now I have negative 11/15 x equals negative 7/15. Now I'm ready to solve for x. How do I get x by itself? So what is the reciprocal? Negative 15 over 11 or 15 over negative 11. As long as the negative's in there, that's fine. Technically does not matter. Get these to cancel. X equals. Now multiply this side by negative 15 over 11. My 15's cancel, but don't forget that's still a negative 1. What's negative 7 times negative 1? Positive 7. No doubt, guys, I'm going to give it to you. This is hard. Okay, this is tough, but it's not impossible. It is a step-by-step process. Okay? I want you now to solve the second one. Solve the second one. Remember, you move what's not connected to the variable first, and then find your LCD before you can add or subtract. Okay, first thing we do is we have to move what is not connected. We need to add 3/9 to both sides. Okay, and now we have 10/27 x equals, but wait, we cannot add them together. What is our LCD?
6.
Nope.
18.
That's okay, but that's not the LCD. The LCD is 18. You can still get the right answer if you created a common denominator. That's fine. Okay, so 6 times what is 18? 3. So, hold on. We got to remember this is going to be negative 3 plus 6. What is negative 3 plus 6?
3.
10/27 x equals 3/18. Now what do I multiply both sides by? 27 over 10. 27 over 10. And now you can cross reduce 2 and 3. And I get x equals 9/20.
Wait, 9/20.
Yep.
Yeah.
3 times 3 is 9. 2 times 10 is 20. Let's do a few more. Now, I want to do one more. Now that we've done 2 with LCD, I want to do one more with LCD. Then we've got another one. This last example, we've got a 2-step equation, but now I don't have to find LCD. It's a whole number. Okay, so 2-step equation with a whole number is a little easier because I do get to skip the LCD step. All right, so let's solve these two. Okay, so we're going to subtract 2/3 from both sides. Subtract 2/3. 7/9 x equals, wait, what's my LCD? 6. So 5/6 stays the same. Minus 4/6. How did I get 4/6? Because 3 times 2 is 6, so 2 times 2 is 4. 7/9 x equals 1/6. Now what do? Multiply both sides by 9/7. I can cross reduce 2 and 3, and I get x equals 3/14. Who got it right? Good job, good job. All right, second one. I'm going to do this one in purple. Subtract 7, 4/9 x. Don't you think this one was easier?
Yeah.
Minus 24. Multiply by 9/4. It's just easier because you don't have to multiply by the reciprocal, or do the reciprocal. Times 9/4. 6. X equals 54. Who got that one right? More. Good. Awesome. Very good. All right, we're going to skip that. Okay, example 3. We've got to do a word problem one. It says, gosh, I wish they would give us a better example. Stalactites. Do you know what a stalactite is? What is it? Yes, it hangs down from the tops of caves. They look really cool. If you've never seen one, definitely put that on your bucket list. All right, so they're icicle shaped. Let me talk. Stone formations found on cave ceilings. They form from minerals deposited by dripping water. All right, so suppose that a stalactite is 10 inches long. Here we go. And is growing at a rate of 1/8 of an inch per decade. How long will it take for the stalactite to reach a length of 1 foot? Okay, 1 foot. So I have here a couple things that I need to consider. One is that how long is it? It's 10 inches. 10 inches. So it says to reach a length of 1 foot, but those are not the same unit. Inches and feet. So whenever I'm solving and I have different dimensions, I want to use the smaller dimension. So how many inches are in a foot? 12. So that's going to be my total. 12 is my total. All right, now, how long is it currently? 10 inches. And how fast is it growing?
1/8.
But I don't know how many decades. I'm going to use D for decades. All right, and then I solve. So I piece it together. I want to start with the total. I think that's easier. That goes on one side of the equation. Then I ask myself, which value is not affected by the variable? Well, it's 10 inches long. It's 10 inches long. Nothing else is affecting that number. But it grows 1/8 of an inch per 10 years. Okay, so obviously that's affected by how long, how many years. All right, so now I just solve like normal. Subtract 10 from both sides. 1/8 D equals 2. Now what do? Reciprocal. How many decades?
16.
Yeah. Isn't it? 16 decades. 160 years. So we'll never see it grow that last 2 inches. If this is right. Okay, if you understand that, that's everything you need to know for 5.6.